Assalamu alaikum and welcome back guys with another lecture of engineering geology. Today our topic is about the minerals, which is basically the continuation of the previous lecture as we have discussed in the previous week. We have week 3 lecture number 3 and me myself I am engineer Abid Ali. So let's start. Okay, we have some kind of minerals which have a metallic cluster. For example, number 1 is we call it pyrite, number 2 galena, number 3 is chalcopyrite, and number 4 we have bornite. These are basically the pictures showing the minerals with a metallic cluster, as we have number A is pyrite, number 2, number 3 and number 4. Okay, we have another mineral name of hematite, a mineral which is composed of iron oxide. Hematite occur in several varieties that have metallic or dark red, brown, non-metallic luster. Regardless of its luster or color, hematite always have a characteristics red-brown streak. As you can see in this picture, this is basically example of hematite, and we have the red-brown color when we have it in the powder form. Okay, the cross sections of mineral samples to illustrate degree of development of cleavage, the tendency for a mineral to break along perfectly flat planes. The cleavage planes are set of parallel surfaces of weak chemical bonding between repeating parallel layers of atom in a crystal. Each different set of parallel cleavage plane has orientation relative to the crystalline structure is in refer to the cleavage direction. Number 1, we have an excellent cleavage direction, reflect light only in one direction from a set of large obvious flat and even surfaces. Number 2, we have a good cleavage direction, reflect light in one direction from a set of small obvious flat uneven surfaces. A good example for that is galena. And number 3, a poor cleavage direction reflect only a small amount of light from a set of very small flat uneven surfaces that are not obvious. Remaining rays of light are reflected in one direction from fractured surfaces. Minerals with no cleavage have no truly flat surfaces, exhibit only fracture, curve and uneven surfaces, and reflect light in all directions. Okay, these are basically the examples of the cleavage of excellent, cleavage of good quality, cleavage of poor, and the minerals which we have no cleavage. So as you can see in these pictures, we have the emitting of light only in one direction on the large, even and flat surfaces. And number B, we have a cleavage of good quality. Also it have emit light only in one direction, but on even small, uneven and flat surfaces. And number 3, we have the cleavage of poor quality, which we have a small flat surfaces and the direction of the light is not only in one direction. And number 3, we have the minerals with no cleavage, and which is basically a fracture, so there is no flat surfaces on this, and the direction of light is not only in one direction, and in the lights we have a several direction on this. This is basically the specific gravity. Okay, here we have is the specific gravity, which is basically easy and useful parameters of the minerals. You guys don't need to just remember these, just go through it. Okay, here we have is the hardness. What is hardness, which is very useful, easy and useful tool. Basically we find the hardness of the minerals by the Mohs scale, which is we have from 1 to 10. The Mohs scale hardness was developed in 1822 by the Friedrich Mohs. The scale is a chart of relative hardness of the various minerals from 1 to 10. From 1 softest to the 10 hardest. Since hardness depends upon the crystallographic direction, ultimately on the strength of the bond between the atom in a crystal, there can be variation in hardness depending upon the direction in which one measures this property. Mohs hardness is a measure of relative hardness and resistance to scratching between minerals. Other hardness scales rely on the ability to create indentation into the tested mineral, such as like Rockwell and Brinell hardness. These are usually meant to determine the hardness in metal and metal alloy. The scratch hardness is related to the breaking of the chemical bond in material creation to microfractures on the surface of the mineral. So generally minerals with covalent bond are the hardest, while the mineral with ionic metallic valence bonding are much softer. So by doing The test of mineral, it is necessary to determine which mineral was scratched. The powder can be rubbed or blown off, and surface scratches can usually be felt by running fingernail over the surface. One can get a relative feel for the hardness difference between two minerals. For instance, quartz will be able to scratch calcite with much greater ease, so they can scratch calcite with fluoride. One must also use enough to force to create the scratch. If you don't use enough force, even the diamond will not be able to scratch quartz. This is the area where practice is most important. So also have to be careful. Test materials that you think that are testing and not some small inclusion in the sample. This is where using a small hand lens can be useful to determine if the test area is homogeneous or not. Okay, what we can say about the fracture in minerals. So in mineralogy, the fracture and cleavage are used to describe the tendency of mineral to break. Fracture and cleavage is nothing but the positioning of the atom that are present in mineral and how it can break when the stress is exerted on it. And while in the geology, we can discuss the fracture is any kind of separation or break in a rock formation. The examples are joints or fault. These divide the rock into two or more pieces. A fracture can sometimes form a deep, wide crack in the rock. They are usually caused when the rock is not strong enough to hold up under too much stresses. Okay, other features are acid reaction, focal side, feel by feel of hand, fibrous, smooth, magnetism, malleability, taste. You guys should be careful with the taste because most of the time it can have adverse effect on your health. So crystal form, which is basically we have rare. Okay, this is the picture of the mineral which showing the magnetism. Another mineral of showing the shape, and then the picture of basically the crystals which we have rare and we have discussed. Mineral association. Some minerals commonly found with others like mafic, felsic, metamorphic, and non-silicates. These are basically the flow chart. You guys just go through it. If you have any questions regarding to this, feel free to ask in the comment section. Okay, this is basically the link of web page for the mineral of hand specimen identification. You guys just go through it. Small mineral with huge importance. Mineral uttered by weathering to sheet, very common in sedimentary rock and soil, depend upon parent mineral and the positional history. The size must be less than 2 micron. Highly plastic, most common in kaolinite, elletite, chloride, and smectite. Bentonite is basically cement additive, capable of expansion with water, addition of water. Too small to identify. We use when we have the mineral which is basically too small to identify, we have different kind of lab tests. Is the petrological microscope. Series of detailed tests allow confident mineral identification. Polarized light passes through the minerals and become rotated, generates phase different in different direction, can tell a great deal about the mineral from its response. Okay, here we have a picture of microscope. You guys must be familiar with this. Okay, here we have a picture which shows a white light passing through the polarizing filters, and we have is different nature like the direction of propagation, vibrational direction of polarized light. Some thin sections of the minerals, as you guys can see in the following figures. Sometimes we have very fine minerals. When too fine to see by visible light, often need laboratory methods. Clay, vital to understand, kaolinite, elite, cementite, bentonite, and most common is X-ray diffraction. SRD is called X-ray diffraction. Is not just for the geology. Widely used investigate tool in crystalline engineered material. Setting of concrete and sand depend on mineral. It takes a long time to form. The concrete may crack and lose its strength. Other issues cracking due to gypsum, sources of aggregate, age of cement. This is basically the pictures of, we have the uncracked and we have the cracked. What minerals are most important to the society? This is in this pictures, as you can see, this one is the UK consumptions tons per year. and we have the main mineral properties and the main uses of these specific minerals here. For example, number one, we have the limestone. The main mineral of this is calcite CaCO3. Main uses of the limestones are filler, animal feed, polymers, paint, paper, pharmaceuticals, agriculture, flux, iron, steel, glass making, chemical, and number two, we have the salt, which is basically main use, it is in chemicals. Just go through it. We have different, just go through these minerals. We have like chalk, fire clay, potash, china clay, phosphate, and their main uses. By now, in the end of this lecture of the minerals, you guys should be able to do the following, like what mineral is, why the understanding mineral property is important for engineers, and describing the criteria for classifying minerals, and recognize that association of minerals occur, a list of alternative methods for identify very fine grained material, and state why we civil engineers need to know about clay material. So that would be all for the lecture number 3. If you guys have any questions, any query, feel free to ask. Thank you so much. Take care. Bye.